Hey everybody, welcome to Solving Trig Equations Level 1. So in this video, we're going to solve equations like the ones that look like you see on the screen. So let's figure out how to do this. There's going to be a method that we're going to be using, and the method that we're going to use might be similar to ones you recognize from solving either linear equations or from solving quadratic equations. So yes, your factoring is going to come back into play. Quadratic formula is also going to come back into play. So in linear equations, when we solved for x, what did we do? We got all the x's on one side, right? And we got all the numbers on the other side. The equivalent statement to that is we need to rearrange the equation first. So it's in terms of only one trig function. So we don't want sines and cosines. We only want sines, or we only want tangents or whatever of the same angle. And then once we get that, we need to, so in order to get that, we need to add, subtract, multiply, divide on both sides, right? Add 2 on both sides, divide both sides by 3, whatever it is, until we get one trig function equals number. That's the idea. Or we have a multiple equals 0, right, in the case of a quadratic. And then you'll see we're going to use factoring and quadratic formula as needed. And we need to consider all values that make the equation true, right? Because we're not dealing with linears anymore. There's not only one value that we're going to see, right? We're looking at periodic functions. So there's actually infinitely many values that it's going to make this true. And we'll see how to express, hey, it's this plus all its infinite equal answers as well. So let's look at how to do that. So to start, let's say I want to solve 2 cosine theta minus root 3 equals 0, and I want all solutions that make this true. And we'll look at it in terms of degree, and we'll look at it in terms of radian. So we'll get every single type of solution that we could possibly have. Well, I need to solve for cosine theta. So let me add root 3 to both sides. That'll give me 2 cosine theta. So you see we're trying to isolate cosine theta. And then we want to divide everybody by 2. So this is like solving how we know. Okay, so I have cosine theta isolated now on the left. On the right, I have root 3 over 2. So your unit circle is going to come in handy for this, right? If you look at your unit circle, where is cosine of theta equal root 3 over 2? Or where is the x-coordinate? Root 3 over 2. Well, we see that theta could equal 30 degrees. And we also see, right, unit circle, we also see that theta could equal 330 degrees. In radians, this is pi over 6, or 11 pi over 6. But trig functions are periodic, right? So I could go around the circle again. And this could be 390 degrees. I can go around the circle again. I can go around the circle again. I can go around the circle again. And there's going to be infinitely many answers that'll make this true if I just keep going around the circle. So how do we express that? In degrees, we would say theta is equal to 30 degrees plus 360, right? Go around the circle. K, and we say where K is any real number. Sorry, not any real number, any integer. So positive or negative, right? Because I could go around the circle backwards also. So theta is 30 degrees and then plus any amount of revolutions that you would like. Or it's 330 degrees plus any revolutions that you would like. In radian speak, so we also saw it's pi over 6 plus, if we're going around the circle in radians, 2 pi times k. Or it's 11 pi over 6 plus all revolutions around the circle as well. So if you need the answer in degrees, if you need the answer in radians, and to account for literally every single other answer, because remember, as you keep going around the circle, okay? So we're going to see our answers expressed like this from here on out. Okay, let's complicate things up a little bit. So 4 sine of x minus root 3 equals 2 sine of x. So think of sine of x as x. I need to get all of my x's right on one side. So I'm going to subtract 2 sine of x from both sides. and I'm going to add root 3 to both sides. In doing that, I would get 4 sine of x on the left minus 2 sine of x. Now I've added the root 3. Basically, I just switch places with these guys. Okay, now all of my sines are in one place. If I have 4 sine minus 2 sine, then I will have 2 sine. So I have 2 sine of x equals root 3. I need to isolate the sine of x. I'm going to divide everybody by 2. Hopefully these steps are looking really familiar, right? This is all stuff we used to do when we were just solving for x. So now sine of x equals root 3 over 2. So where does sine of x equals root 3 over 2? Well, it equals at 60 degrees. And then if it's 60, then plus 360k. So all revolutions also. If we look at our unit circle, sine of x equals root 3 over 2, also at 120 degrees. That's a degree up there. Plus all revolutions, so plus 360k. In radians, this is pi over 3 plus 2 pi k. Or it's 2 pi over 3 plus 2 pi k. Remember, the 2 pi k is we're just accounting for now all revolutions. Same thing with 360 times k. We're just saying, hey, any coterminal angles are also true values for this as well. Okay? Next example, and we're going to keep kind of kicking up the complexity here. You know what? I don't white. Red and white. Never red and white. Okay. So what about something like this? I have tangent of x times tangent of x minus 1 equals 0. So think back to when we were solving. What do we do with this? Hey, I have a product equal to 0. If I have a product equal to 0, I can set each term equal to 0, right? Or tan x minus 1 equals 0. Because we have a product equal to 0. So where is tangent equal to 0? Well, tangent's equal to 0 on the unit circle whenever it's flat, right? Because tangent is slope. So x is either 0 plus 360k, or x is 180 plus 360k. In radians, it's still 0 plus 360k, or it's pi plus 2 pi k. So that takes care of this guy here. Okay, now let's take care of this piece of the product here. Add 1 to both sides. We'd get tangent of x equals 1. Okay, where is tangent of x equal to 1? Unit circle, where is tangent equal to 1? Well, it's equal to 1 at the 45, or the pi over 4. So at 45 plus 360k, 45, and if you go all the way around the circle, 225 plus 360k. In radians, that's pi over 4 plus 2 pi k, or it's 5 pi over 4 plus 2 pi k. Now, you don't need to answer all of this every single time. It just depends. Are you getting your answer in terms of degrees? Then use, of course, the degrees. Or are you being asked in terms of radians? And use the radians. I'm just showing every possible form of the answer here. Okay? So again, products set equal to 0. Set each product equal to 0 and solve it individually. Again, hopefully this is ringing a bell. These strategies are still the same that we used to use when we were solving for x or y or z or whatever. Let's switch to green. Okay, how do we solve this? Well, again, think back. So I have root 3 tan theta minus 2 sine theta tan theta equals 0. I don't have a product because there's a subtraction here. This is not a product. This is a difference. So I can't set that equal to 0 and that equal to 0 and solve it. That's not going to work. But what I can do, I notice there's a tan theta in this term, and I notice there's a tan theta in that term. I can factor out. If I factor out tan theta out of both of these terms, I basically take it out of the first term, so I'm only left with root 3. And I basically take it out of the second term, so I'm only left with minus 2 sine theta equals 0. Now I do have a product. If I have a product, I can split it, and I can set them both equal to 0. Tan theta equals 0, or root 3 minus 2 sine theta equals 0. Where does tangent equal to 0? We just saw it. It's at 0, or it's at, not 360, excuse me. It's at 180. Plus 360k. In radians, 0 is still 0. Or pi, plus 2 pi k, plus 2 pi k, plus 360k, plus 360k, right? Make sure you're counting for revolutions. To solve this, let's subtract root 3 from both sides. So we'd end up with 2 sine theta. 0 minus root 3, we'd have negative root 3 over here. Let's divide everybody by negative 2. So all we're doing is we're just trying to get sine theta by itself, right? Boop. Negative over negative, that's positive. Where does sine theta equal root 3 over 2? I feel like we've seen this before. Theta is going to equal 60 plus 360k, or it's going to equal 120 plus 360k. In radians, pi over 3 plus 2 pi k. K just means all revolutions, or 2 pi over 3 plus 2 pi k, right? I just didn't write the 360k or the 2 pi k over here. So you may be called to factor, right? So every tool that you have in your toolbox that you learned way back when you were solving linear equations, when you were solving quadratic equations, when you had to factor equations and then set both of them equal to 0, all of that is still applicable here. And even more so, let's look at some stuff now where we even have to pull out some quadratic formula. So I have a square, a linear term, and a constant term, right? Something squared minus something minus number. What if I knocked out the sign, right? Ignore the sign for a second. 2x squared minus x minus 1. This looks like something we've seen before. So let sine of x right now just equal y. Okay, why? Because it just makes our brain feel better. So for every sine of x, I'm going to take out the sine of x and I'm going to replace them with y. And now this looks like something familiar. So we would have 2y squared minus, this is now y, minus 1 equals 0. How do we solve this? Well, we could either factor it or throw it into quadratic formula. For old time's sake, I'm going to use quadratic formula. There's a, there's b, there's c. Quadratic formula, negative b plus or minus square root b squared minus 4ac all over 2a. B is negative 1, so negative negative 1, positive 1, plus or minus square root b squared minus 4 times a times c all over 2 times a. Okay, so y is going to equal all of that. Let's simplify this. 1 plus or minus negative 1 squared is 1. 4 times 2 is 8. 8 times negative 1 is negative 8. So this is all going to turn into 1 plus 8 over 4. 1 plus 8 is 9, and the square root of 9 is 3. So this is going to be 1 plus or minus 3 over 4. So y is going to equal 1 plus 3 over 4. That's 4 over 4. 1 or 1 minus 3 is negative 2. Negative 2 over 4 reduced is negative a half. So y is equal to 1 or negative a half. That's great. But now let's back substitute. Y is sine of x. So sine of x equals 1. Or sine of x equals negative 1/2. Okay? Where does sine of x equals 1? Well, x would either be 90 degrees or 90 degrees. Plus 360k. Or pi over 2 plus 2 pi k, depending if you wanted it in radians or degrees. Where does sine equal negative 1/2. Well, x is going to be 330 plus 360k, or 11 pi over 6 plus 2 pi k, or 210 plus 360k. So remember, go to unit circle. Look at your unit circle. Where you see your y value equal negative 1/2. Well, the y value is negative 1/2 at 330, or 11 pi over 6, again, depending if you're using radians or degrees. Or, right, if we kind of take symmetry here on the unit circle, we look back over to 210. If you look at 210, you'll also see that the y value is negative 1/2 there as well. And then this is going to be 7 pi over 6, 2 pi. Okay. All right, so some quadratic formula as well. Basically, just treat sine as x. In this case, I treated sine as y. And I solved as if I was solving a quadratic formula problem instead. And then once I got my answers, I kind of back substitute and be like, okay, well, I'm not actually solving for y, I'm solving for sine. And then I set sine equal to both answers that I got. And then I solve from there like we've seen. So let's see another one of those, because those are really exciting. So this isn't set equal to 0, so I can't just start off in quadratic formula. So let me subtract 4 sine of theta from both sides. Try it in white again. I like the white. So we have 4 sine squared theta minus 4 sine theta plus 1 equals 0 now. Okay, great. Now I'm set up for quadratic formula. Let's again let y, and you just choose your favorite letter here. Let y equal sine theta, which means boop, boop. All those are now y's. So now I'm solving for y squared minus 4y plus 1 equals 0. Quadratic formula. A term, B term, C term. Let's plug it in. Negative B. B is negative 4, so negative B would be positive 4. Plus or minus the square root B squared is 16 minus 4 times A, which is 4, times C, which is 1, over 2 times A, which is 4. So y is going to be equal to this, and then we're going to back sub y for sine. So that's going to be 4 plus or minus the square root of 16 minus 4 times 4 is 16 times 1 is 16. 16 minus 16, that's going to end up being a 0. 2 times 4 is 8. That ends up being a 0. 4 plus or minus 0 is still 4. So this is 4 over 8, which is 1/2. Y is sine. So because we solved, okay, well, y equals 1/2. That's great. But remember, we substitute y and sine. So now sine, at the end, change y into sine. So now where does sine equal positive 1/2? Well, theta is either going to be 30 plus 360k, or let's look at the reflection, 150 plus 360k in radians, that's pi over 6, plus 2 pi k, or again, look at the reflection, 5 pi over 6 plus 2 pi k. Right, so another example of how we can use quadratic formula to solve trigonometric equations, which is pretty cool. So that was everything for this video. This was the level 1 video. In the next videos, we'll see how to solve trig equations with a couple variations, because there's some other weird stuff that can happen. Like, what if we have more than one trig function? What if we have multiple angles? What if we have a bunch of different other kinds of stuff? So that we'll see in the next video. Okay? As always, if you guys have any questions, please don't hesitate to ask.